Welcome to the Envision for Backtalk Basics course. My name is Linda. I'll be your guide throughout this course. In this module, I'll discuss the background of BACNet control systems and the terms you'll need to know to understand building control systems using Allerton controllers. This isn't an overview or an introduction. This module contains fundamental concepts and terms that you must know and understand to successfully complete this course. Be sure you understand and remember the information in this module before you continue to another one. On completion of this module, you'll be able to list key characteristics of the BACNet standard, what it is and what it defines, list the 4 levels of the BACtalk system architecture and the Allerton products in each level, identify the role of Envision for BACtalk in a BACNet system, list and describe 3 BACNet network types, describe the numbering in a BACNet network, list and describe 9 BACtalk objects that represent types of data points, identify the relationship between objects and properties, and identify the defining features of a closed-loop control system. We have a lot to accomplish in this first module. Let's get started. BACNet is an acronym for Building Automation and Control Network. The American Society of Heating, Refrigeration, and Air Conditioning Engineers created the BACNet standard. The American National Standards Institute, ANSI, has adopted it as a national standard. BACNet is a non-proprietary standard protocol that encourages different control manufacturers to provide products that communicate as a part of a single control system. BACNet prescribes a set of rules for representing and transmitting data between controllers on a network. It specifies a common object-oriented language for representing system data, and it identifies the media required for data transmission. The network media are a mix of new and existing network standards. For instance, Ethernet is an example of an existing standard, while the MSTP at the field controller level is an example of a media type defined by BACNet. You can find most of the information we'll be covering in this module in the Envision for BACtalk Operator's Manual, Chapter 1, in the section What You Need to Know. You can get the Operator's Manual from your Allerton dealer in print or electronic format. BACtalk is Allerton's implementation of the BACNet standard. Envision for BACtalk is Allerton's window-based program used to configure and communicate with a BACNet compliant system. Envision monitors and commands BACNet devices within a building automation system, whether the devices are manufactured by Allerton or by another BACNet vendor. There are 4 levels in the BACtalk system architecture: the sensor actuator, field controller, integration, and management levels. I'll define these 4 levels and identify the Allerton devices that operate in each. Starting from the bottom, the sensor actuator level is where all input and output devices reside. This includes Allerton manufactured room sensors such as the Microset, the Microset 2, MicroTouch, and the stainless steel wall plate. Other types of monitoring and control devices such as humidity, CO2 sensors, valves, and actuators also live at this level. Next is the field controller level. All of Allerton's visual logic controllers, or VLCs, reside here. These devices are called unitary controllers in the BACNet spec. Allerton's VLCs are fully programmable controllers that support a full range of HVAC applications, such as VAV boxes, unit controllers, heat pumps, air handlers, and large central plants. Devices at the sensor actuator level below are the inputs and outputs for the field controllers. The field controllers are connected over a BACNet MSTP, or Master-Slave Token Passing, local area LAN, to devices at the sensor actuator level. Above is the integration level. Allerton Global Controllers and BACNet Building Controllers reside at this level. Allerton's Global Controllers store BACNet objects such as trend logs, schedules, and alarms, and are fully programmable using Allerton's Visual Logic program. Devices at the integration level connect to devices at the field controller level below via an MSTP network. The integration level and the management level above are connected by an Ethernet LAN. The integration level and the field controller level are connected by an MSTP LAN. The Envision for BACTalk server and client workstations reside at the management level. People from tenants and operators to system engineers work at this level to design, commission, monitor, and maintain a BACTalk system. The Backnet standard calls out 5 different network media types. However, Allerton's Backnet products only use 3 of those 5 types. Those 3 are: Ethernet is a high-speed data network over which devices at the management and integration levels communicate. MSTP stands for Master-Slave Token Passing. Master-Slave refers to the Backnet devices. Token passing refers to the method of managing the communication between devices. All Allerton devices are Backnet master devices. The MSTP network connects the field controller and integration levels. PTP stands for point-to-point. This type of network is used for temporary connections using modems or direct connect, EIA-232 serial cables. A Backnet inner network is created by joining 2 or more Backnet networks with Backnet routing devices, such as Allerton's BCM ETH module or BLX. I'll tell you more about Allerton devices in another module. In any network, it is crucial to clearly identify each device uniquely. Each network in a Backnet control system has a unique identifier called a network number in the range of 1 to 65,534. Think of network number as a street name in a city. For mail to be delivered properly, each street name must be unique. The Postal Service would have difficulty with 2 entirely different streets named Pine in the same city but in different sections. It's even more critical to uniquely identify each device in the Backnet system. Every device also has a unique physical identifier called a MAC address. MAC is short for Media Access Control. MAC address is somewhat like a house number. The device's network number and MAC address identify the device as unique in the Backnet inner network. Each device on a Backnet network has a third unique identifier called the device instance. Device instance is a number from 0 through 4,194,302. Each device on the network uses device instance to address other devices on the network. In Allerton systems, device instance is a first part of any reference to point information, such as temperatures and set point. The Allerton dealer who designs the Backnet control system painstakingly plans the network numbering scheme. Just like the combination of street name and house number works for the Postal Service, device instance is a reliable way to reference a Backnet device. Not only does the Backnet standard specify network types, it also defines types of information that are referenced within a device. Some objects in a Backnet system are analog. This means the value of the object varies along a range. Measures of temperature, humidity, and valve position are analog values. Each type of object is further identified as input, output, or a value. The top row lists analog objects. An example of analog input is a point on a controller that monitors temperature from a sensor. A controller uses analog output to open or close a valve to a percentage of full open. Some objects are binary. A binary object has only 2 states, on and off. A controller would monitor fan status through a binary input. It would turn a fan on or off via a binary output. A controller uses analog value and binary value objects to store information for use by its programming. Controllers use value objects to store calculated values, cooling signal, heating signal, and runtime hours, set points, economizer minimum position, and other data that its control program requires. We refer to these objects by the first letter of each term. For example, analog inputs are called AIs. Binary values are called BVs. Other BACNet objects you'll learn about soon are trend log objects, event enrollment objects, a fancy way of saying alarms, and schedule objects. The BACNet spec includes multi-state objects. They are similar to binary objects, but instead of only 2 states, they can have 3 or more. For example, a fan command object can have 4 possible states: off, low, medium, and high. Allerton does not use multi-state objects in any of its devices, but Allerton controllers can read and control them from other manufacturers' devices that do. You now know how to find a device on a network using its device instance. You know that each device has objects to monitor, control, or values to record. For example, an analog temperature reading, a binary fan control, or occupied status. An important concept of BACNet systems is that each object has 1 or more properties. Most of the time we use present value, though there are other properties. Present value is the current value or state of the object. For example, if AI1 is the supply air temperature, its present value property could be 71. Suppose we consider an automobile as an object with properties. We could say that the color property of the car is red, that the body style property is sedan, or that the manufacturer property is Ford. To properly refer to any point in a BACNet system, you state 3 pieces of information. First, the device instance of the device where the object is located. This identifies its location in the system. Second, you indicate the object ID, which is the type of object, AI, BO, and so on, and a number that indicates its location on the controller. For example, if the outside air sensor is wired to input 1 on the VLC, we refer to that point as AI1. The object type is analog input, and the instance is 1. Third, the property, generally the present value. So a complete reference to a BACNet object reads, for example, device instance 1001, analog input 1, present value. Here's an illustration of the interaction of objects and properties with the BACNet network. On the left is a wall-mounted temperature sensor, which functions at the sensor actuator level. The center rectangle represents the Allerton VLC with the sensor physically wired to the analog input AI0. The number 0 is called the instance. Inside the square are some of the properties of the AI0 object. The present value property has a value of 71. Some of the other properties are the description property, space temp, the device type, 10K thermistor, the out-of-service flag, false, and the engineering units, degrees Fahrenheit. The VLC communicates over the BACNet network. When a global controller requests the present value of AI0, the VLC replies that AI0 present value is 71. Envision might display this value, or the global controller might use it in its programming. Let's review the most commonly used BACNet objects. Analog inputs, AIs, and binary inputs, BIs, are physical input connections to Allerton controllers. These points monitor devices that are at the sensor actuator level. You don't change these, you only monitor them. Analog outputs, AOs, and binary outputs, BOs, are physical output connections on Allerton controllers. Controllers use these objects to control hardware devices such as valves and fans that are at the sensor actuator level. The DDC control program running in the Allerton device uses analog values, AVs, and binary values, BVs. They aren't tied directly to physical devices. I've pushed a lot of information at you that you'll need to understand and recall as you continue the course. You might find it helpful to review BACNet addressing, objects and properties in the operator's manual or in this module. The 2 types of control systems are closed loop and open loop. This illustration shows a controller in a closed loop control system. The controller is any BACNet unitary controller, such as an Allerton VLC 1188 or VAV controller. The controller reads inputs and controls outputs to maintain a given set point for the supply air temperature. The controller commands the controlled device. Here, it's a chilled water valve, to respond to changes in the system. This illustration shows a controller in a closed-loop control system. The controller is any BACNet unitary controller. If the room gets too warm, it opens the chilled water valve. If the room is too cool, the controller reduces the valve opening. Changes in the flow of the cooling liquid, the controlled medium through the coil, affect the temperature of the air. The feedback sensor reads the temperature of the supply air. Closing the loop, the controller reads the feedback sensor and opens or closes the valve to reach the set temperature. Feedback to the controller is the component that defines this as a closed-loop control system. This illustrates an open-loop system. There is no feedback sensor. Command of the controlled device is based on the known or expected effect that changes to the controlled device have on the controlled medium. For instance, if we know that with the cooling valve at 0%, the air supply temperature will be 65 degrees Fahrenheit, and with the cooling valve at 100%, the supply air temperature will be 55 degrees Fahrenheit, then a 50% command should result in a supply air temperature of 60 degrees Fahrenheit. Now you should be able to list key characteristics of the BACNet standard, what it is and what it defines, list the 4 levels of the BACtalk system architecture and the Allerton products in each level, identify the role of Envision for BACtalk in a BACnet system, list and describe 3 BACnet network types, describe the numbering in a BACnet network, list and describe 9 BACtalk objects that represent types of data points, identify the relationship between objects and properties, and identify the defining features of a closed-loop control system. You can find the information we covered in this module in the Envision for BACtalk Operators Manual, Chapter 1, in the section What You Need to Know. Be sure you understand and remember the information in this module before you continue on to another one. This concludes our BACnet Basics module. If you're taking this course in its entirety, please continue to the next module in this series.